Hello, my name is Joey Salazar, and today I'll be presenting on the paper How Does Memorization Impact LLM Social Reasoning? And this study is coming out of the University of Washington. The main goal of this paper is to essentially measure whether LLMs are responding meaningfully and reasoning correctly rather than are they just repeating whatever context they were trained on. And so that's what we are aiming to answer. And if they are just repeating whatever they were trained on, the goal is to minimize that and to actually ensure that they are reasoning correctly, like how a human would. So, just to go over what we're going to cover in this presentation, it's obviously the motivation, as I kind of summarized right now, the reasoning or the memorization part of LLMs. We're going to hopefully answer two of the main research questions of this paper. We're going to recap some key concepts so that we're all on the same page. Then we'll go over the related works and the improvements that were made in this paper, or essentially what this paper is actually targeting. We'll review the data that was used and how the experiment was conducted. We'll review the data, evaluate the metrics that it spit out, and actually take a look at the graphs that were provided in the paper. Then we're going to review an actual example of how they conducted one of the queries, and then we'll wrap up. So without further ado, what's the motivation? So consider two sets of researchers. Half of them currently believe that LLMs are actually capable of reasoning, and the other set believe in memorization. So what does this actually mean? It's in set A, the ones that believe in reasoning, is that the LLMs understand basically natural language. They can reason and make deductions and apply the knowledge that they were trained on. And in set B, these researchers believe that LLMs are mostly just regurgitating whatever context that they were trained on. And obviously in set B, that's not ideal for people like you and I who are using LLMs to make advancements or help with day-to-day tasks that aren't binary, where it's just a hard set definition or answer that is correct. So are either sets of these researchers necessarily correct? Well, currently there's not a lot of evidence to prove or disprove either set. We're missing a lot of these answers for whether good answers are memorized or genuine understanding. And that's the main goal of this paper is, can we ensure that LLMs are reasoning accurately and logically? So the research questions that we want to consider. To what extent can LLMs do zero-shot human-like social reasoning on seen versus unseen queries? This is the really big thing. We can't test this if we're just giving an LLM something that it's already been trained on. That would defeat the entire purpose of conducting this research. So we need to give it queries that it has seen before, measure the responses, and then we need to give it queries that it has not seen before and measure those responses to come to a conclusion. And then if we can do that, how effectively can we minimize the memorization effect in the reasoning? So like I said, if the LLMs are relying heavily on the memorized context that they were trained on, how can we bring that down and ensure that they are, in fact, giving us an understanding of what it's outputting? So hopefully by the end of this presentation, it's a lot more clear. So some of the key concepts is the social reasoning aspect and the seen versus unseen part. So as I had mentioned before about the binary output of the memorization effect, a way to think about this would be a student studying for an exam. If you have an exam that is purely definition based, there's one single answer. A student could ace that if they just take the time to study, memorize the definitions, and go ahead and complete it. But if you're given another exam where you need to apply the concepts that you were taught in class, that would be the reasoning part of, can you deduce how to apply the knowledge that you have already seen. And that leads into, again, the seen versus unseen queries. providing the LLM with a query that it's already been trained on versus some queries that it has never seen before. And then from this, we'll capture some metrics and we'll look at the deltas, or the difference between seen versus unseen, and from there we should be able to capture the memorization effect. So leading up to this paper, they use these 4 approaches for essentially how they are going to query the 4 LLMs. And the first one, it's called chain of thought. So essentially you're giving the LLM a list of instructions on how to attack the query and how you want it to answer. And it'll go step by step. It'll in hopes of getting the LLM to follow a more formatted approach. With information retrieval, before we are giving the LLM a query, we're running it through GPT-4o Turbo, and we are extracting entity relation triples from the title and the body of the query. And then this will pull out exactly that entity relations, basically key concepts or keywords in the query to give the model to consider when answering. Another approach for giving the LLM's queries is step back prompting, essentially asking the model to abstract the original question, look at it at a higher level, and then from there dig down into what it's actually being asked to produce. And finally, this paper also uses reasoning of graphs, which is where you give an LLM a relation graph, and a lot of times it also is including external knowledge. Based on this, something that I had trouble understanding at first is really what's the difference between information retrieval and the reasoning of graphs. And essentially in information retrieval, it's flat triplets, so it's just text essentially that's being given to the LLM. And in the reasoning of graphs, it's exactly what it sounds like. It's a graph of knowledge, so that it can traverse knowledge on the query in a more formatted approach. In this paper, it does not use external knowledge to try and keep the results more balanced. However, typically in the reasoning of graphs, you have a graph of knowledge from an external source that allows the LLM to have more background knowledge and to reason more meaningfully. So this is kind of how the researchers went about this paper. They are combining the chain of thought with information retrieval. In the past, in previous research, the 4 that we just went over were done independently. And these researchers decided to combine chain of thought with information retrieval. So if you look, there's an instruction prompt with a title and a body, and that's what it's using. And it's asking the LLM to pretend that it was a user on a platform for facilitating reasoned responses. I'll get into that. We were using Reddit and Lemmy for this research. Then we have the retrieved data, which is the information retrieval, which is the entity relation triplets that I just covered. And then finally is the chain of thought, the instructions for the model to consider. And here the researchers gave it 3 steps to follow before answering. So as I mentioned, the data for this was from Reddit and Lemmy. For most of us, we should be pretty familiar with these. It's forums where people can ask questions and answer them open-endedly. And again, that's the point of this paper, is we don't want to go something where there are necessarily correct answers. We want to measure the LLM's ability to reason. And so that's why they chose Reddit and Lemmy. Through Reddit and Lemmy, there were 845 queries from each in the seen and unseen pool, and each query has 5 human answers. And for each query that they were feeding the LLM, they asked it to produce an answer 5 times. And so again, we have the input question, then we're going to do the information retrieval, give it the chain of thought reasoning, and step 4 is just getting the 5 answers. And this is, again, the bread and butter of the research paper. They just want to basically execute IR and chain of thought reasoning to see if it is better than the 4 independently. So how do we measure this? The research paper decided to use these 4 metrics. In Rogue L, this is just an F1 score for the lexical approach. So think of it as looking for n-grams that are exactly the same across the LLM generated response and a human response. Again, it's purely lexical. For BERT score, this is a pre-trained embedding model, so we're feeding the tokens in, creating an embedding on them to get the semantic meaning. For the human answers and the LLM answers, and then we're going to go ahead and compare the similarity between, did the responses mean the same thing between the human and the LLM. And then finally, we have 2 Roscoe metrics, and these are essentially the final step of validating the above 2. We're going into, did it answer the same? Did they mean the same? And then finally, did it reason the same? So in Roscoe essay, it's looking for the alignment on logic. And then in the final Roscoe LI, we're looking to find basically if there's any inconsistencies in the reasoning itself. So again, we're going lexical, semantic, and then finally reasoning and logic. So looking into the graphs, we're just going to begin with the basic output lengths. So if you can see on the green lines, the light green ones I should say, the humans typically answered pretty short. And Llama 2 actually did as well. However, in GPT-4 and GPT-4o, the responses were a little inflated. And based on my personal experience with LLMs, this is also a common occurrence. The researchers purposefully did not limit the character output for this reasons that they could measure, if it's memorizing, it might just re-spit out a bunch of memorized tokens and words. So this is just, we can't really deduce anything from this, but it is interesting to see that the GPT-4 ones were producing a lot more words in their responses. For the baseline, the researchers first, they didn't do any of the 4 approaches or formats that we covered, information retrieval, chain of thought, and so on and so forth. They were purely just giving it the title and body, and then they were computing the scores. So this is our baseline. The numbers shouldn't mean too much for now. However, to point out, we're essentially measuring the delta, as I had mentioned in one of the beginning slides. So in the scene ones, we'll just take an example. The BERT score in GPT-4o was a 0.326 for semantic meaning. And when you compare that to an unseen query, that one scored a 0.183. So that delta is pretty high. So the researchers are saying because this is so high, that difference is basically the effect of memorization. So our goal is to minimize this delta as much as possible, and then we can say that the memorization was in fact reduced. So now going into chain of thought, the step back reasoning of graphs, and then the researcher's approach of combining information retrieval and chain of thought. We can see the bold ones are the highest score of all of these, and in the scene queries, not a single one beat information retrieval and chain of thought reasoning. They all scored significantly higher than the others, and when we take a look at the unseen queries, we can also see that almost all of them score the highest in all 4 metrics for information retrieval and chain of thought reasoning. And we're going to take a look at it on the next slide as well, but we can see that the deltas are much lower when comparing seen versus unseen for a given model and a given approach. So again, touching back on the deltas, the top left is what they call the vanilla prompt. So If we take, for example, the Reddit one for the BERT scores, these scored at almost a 14% difference in semantic reasoning. And even in the Roscoe essay, that one gets up to 16%. And on Lemmy, the Roscoe essay is about 17%. When we take a look at the deltas for the information retrieval and chain of thought reasoning against seen and unseen queries, the highest one that we're seeing is about an 8% difference. So this is already a good sign that we're able to minimize the memorization effect in these LLMs. We're forcing them to reason through these methods, which is really good in proving the point of, can LLMs reason like humans? And just so that we can get a better idea of what's actually occurring, this is kind of an example of what the researchers actually gave the LLM. On the left side, this is like a vanilla output, and on the right hand side, that is the information retrieval and chain of thought output. One thing to note on the left side is that it didn't reason as well, and again, that is the entire point. For example, there's a sentence in here, I believe it's this one. By incentivizing ethical AI deployment and encouraging companies to develop technologies that complement rather than replace human labor, we can promote a balanced approach to automation. It's not really answering a whole lot, it's just words, and it's essentially taking that from the body. Whereas on the right hand side, it's really giving a reasonable output for for the effects of forcing companies to give universal basic income if they choose to replace workers with AI. And another thing to point out is this is the entity relation triples that I had mentioned in one of the beginning slides. So from this query, it pulled out these AI systems will replace human workers, so on and so forth. And again, this was used with GPT 4.0 Turbo to get these triples. So the conclusion of this is that the chain of thought and information retrieval, in fact, made improvements across all the metrics in all of the LLMs, and it greatly reduced the deltas in the vanilla approach and in the chain of thought and information retrieval. So in the end, they were able to conclude that they could mitigate the memorization effect, which is a really big win for them. The one thing to note, however, is if we go back to this slide, I had mentioned that the researchers produced 5 outputs versus 5 human responses. So what did they do there? Well, they created a cosine similarity 5x5 matrix, and they scored each LLM response against 5 of the human ones. And they decided to choose the highest performing LLM one. So some of these numbers may in fact be inflated because they're choosing 1 out of 5 and then picking the best one. So that's something to consider about this study that may not be exactly accurate. However, this is how they chose to present their data. And another thing to consider is that these scores are being scored against the human output, so it's not looking for actual correctness, it's just looking at, was it similar to the human response? So if the human response was incorrect, the LLM was incorrect, but the logic and the semantic reasoning was the same, it would still score very high. And that wraps up my end. Hopefully you guys enjoyed this presentation and you guys were able to learn something valuable. It was really nice to read over this paper and see how the researchers approached this. Thank you, everyone.